The lungs of our planet just stopped breathing, and almost nobody noticed. For decades, we were told the Amazon rainforest was Earth's insurance policy against climate collapse. A living vault holding an estimated 123 billion tons of carbon, more than any other ecosystem on land. We assumed it would always be there, quietly pulling carbon dioxide out of our air. But scientists just confirmed something terrifying: that insurance policy can be canceled, and it's already happened once. Here's how it works. Trees breathe through tiny pores in their leaves called stomata. Through these pores, they pull in carbon dioxide and release oxygen, the process we call photosynthesis. But when temperatures spike and water disappears, trees panic. They slam those pores shut to stop losing moisture. The problem? Closing the pores also cuts off their carbon supply. The tree stops feeding. And when this happens across millions of square kilometers of rainforest at once, an entire continent's forest can flip from absorbing carbon to leaking it. This isn't a hypothetical. Researchers led by Dr. Amy Bennett at the University of Leeds, working with over 100 scientists across the globe, studied what happened during the 2015 to 2016 El Niño, a natural warming cycle in the Pacific Ocean that periodically supercharges global temperatures. Before that El Niño, South America's tropical forests were quietly storing about a third of a ton of carbon per hectare every single year. During the event, that number collapsed. The forests effectively stopped absorbing carbon altogether. In parts of the southeastern Amazon, on the edge of the rainforest, trees didn't just stop storing carbon, they started emitting it. Scientists estimate the heat and drought triggered roughly 1.6 billion tons of carbon loss from forest biomass, as trees died and began to decompose, releasing decades of stored carbon back into the sky. Now here's the part that should worry you. El Niño events are not staying the same. There have been twice as many very strong El Niño events in the last 60 years compared to the 60 years before that. And in 2023, another El Niño developed, this one bringing record-breaking global heat unlike anything measured before. Scientists analyzing that year found that reduced photosynthesis across tropical forests was the single biggest driver behind a dramatic slowdown in Earth's ability to absorb carbon. Some researchers now believe we may be witnessing the early signs of a long-term decline in the tropics' power to soak up the carbon dioxide humanity keeps pumping into the atmosphere. Think about what that actually means. For over a century, tropical forests have acted as a buffer, quietly absorbing a huge share of human carbon emissions before they could build up in the atmosphere. That buffer bought us time. It slowed the pace of warming. But if extreme El Niño events keep intensifying, and if forests keep switching from carbon sinks to carbon sources during these events, that safety buffer starts working against us instead of for us. The very system we relied on to fight climate change could start accelerating it. And this isn't just an Amazon problem, or a South America problem. The Amazon alone contains more stored carbon than most industrialized nations emit in a century combined. If a meaningful fraction of that carbon returns to the atmosphere through repeated die-offs and fires, it doesn't just affect regional weather, it changes the trajectory for the entire planet. Every one of us breathes air shaped by decisions made in a forest most of us will never visit. Scientists are now racing to understand whether this is a temporary shock forests can recover from, or the beginning of a permanent shift. The honest answer right now is, we don't fully know. What we do know is that the pattern is repeating. The El Niño events are getting stronger, and the data from the most recent event lines up disturbingly well with what happened in 2015 and 2016. So here's the real question this research leaves us with. If the ecosystems we've been counting on to clean up our carbon mess are starting to break down, what happens next isn't just a scientific curiosity, it's a countdown. What do you think? Can the Amazon recover if these extreme El Niño events keep getting stronger? Or are we watching a tipping point happen in real time? Drop your thoughts in the comments, and follow this page for more science stories that actually matter.